Cool. And all right, I believe we have started recording. So just give me a sec. Let me just verify. And, yeah, cool. We should be good. All right, let's start. If you guys are here, you guys are probably here for the FEA Milestones course. If not, you guys are probably in the wrong spot. But yeah, welcome. Gonna introduce myself in just a little bit. You guys can just scan this real quick. I'll keep this up for like a minute or two. I just want to know who here. Yeah, like I just want to see the attendance basically. If you guys are watching the recording at home after the class is over, please do still scan this. This just helps me and lets me know sort of like who watches the recordings. So thank you. I'll keep this up for another like 20 seconds or so, and then I'll move on. And while I have you guys here, I want to emphasize again that if you guys can't make the meetings every week, that's fine. But please do watch the recordings every week and scan the attendance QR code every recording, so I can note down that you guys have either watched recordings or have gone through the presentation. And okay, I think that's enough time. If you guys didn't get the attendance QR code, please look back at it on the recordings or through the link I'll be posting on Slack. Let's move on. So I'm gonna introduce myself a little bit. So my name is George Lapan. I am from Indonesia and I'm currently a second semester sophomore in mechanical engineering. Well, I'll be a second semester sophomore this coming fall. And I have a little experience in CAD, working with NX through CGT, of course, Fusion 360 and SolidWorks as well. And my experience in FEA is just Fusion 360. I actually started exactly where you guys are today. I took the FEA course this past fall, and I've sort of been working my way up as a TA last semester, and now I'm an instructor. So yeah. And next, I just want to explain a little bit on what a Milestones course is, especially to those of you who are taking a Milestones course for the first time. It's basically, let me just go through this. Cool. Okay. Yeah, so it's supposed to supplement your coursework. I like to think of it as an introductory course. Yeah, so basically, you guys know there's a Milestones course called Intro to Electronics, as well as Arduino, CAD training. So all these courses sort of get into different topics. We just sort of touch the surface. We're not really going too deep into it. But if you guys do enjoy these courses, then you guys can get deeper into it and maybe take more classes on it. And what you'll be receiving at the end of each Milestones course is a digital certificate from Purdue. And it should come like a month after after your finals, depending on what semester you're taking this in. So since you're taking it in summer, you guys should get it about like mid-September. If you guys don't get it by mid-September, be sure to email me or email the Milestones department. I sent all your information to the department, so they should have you on their database. So yeah. Next up. All right. So what are the course objectives of this FEA course? So first is, I guess the core is, I'd like you guys to understand the importance of FEA or FEM. So FEA, again, finite element analysis. FEM is finite element methods. And next is, I'd like you guys to be able to perform a structural analysis on a CAD model, and more specifically on Fusion 360. Right. And next is, I'd like you guys to be able to understand what exactly you're seeing. You know, when you guys do your studies, do your analysis, I'd like you guys to be able to look at the results and really understand what's going on and not just see like a bunch of colors and be like, oh, yes, that's good. And Yeah, lastly, I'd like you guys to be able to um, sort of edit your CAD models if the results aren't what you expect it to be. And we'll actually learn to do that in week 2. So I won't really get into it right now, since we'll be touching on that a lot on week 2. Okay, cool. So here's how the course will be structured. We'll have 5 lectures, and each lecture will be covering an individual module. So first, the one we're on today is an intro to finite element analysis, and we're gonna sort of touch on Fusion's interface, but I expect you guys to know Fusion's interface already. If you don't, please email me. So maybe we could like schedule like a one-on-one where I could show you guys the basics. But besides that, I'd like to get you guys into FEA itself on week 1. We're going to do a static stress analysis on the Fusion file that you guys should have gotten through the email I sent about like an hour ago. And next, we're going to take a look at the difference between doing an analysis on linear versus non-linear materials. Next week, we're going to be doing mesh improvement, and also I'll assign a personal project for you guys. Week 3, we're going to be looking at structural buckling. Week 4, dynamic event simulation. And week 5, I'll dedicate that entire week to a personal project, which will be on structural buckling or dynamic event simulation. Now, before we go any further, do you guys have any questions for me? And by the way, if you guys do have questions throughout the lecture, please just drop it in the chat or just unmute yourselves. But if not, I'll just keep going. And another thing I want to note is this summer course is going to be a bit different. So during fall and spring, this is basically what we're covering, what we'd be covering. So this summer, I'd like to try something new because in previous semesters, students have commented that they want to learn more, and they've been saying that these modules aren't like a lot, and they expected more from the Fusion this FEA course. So that's why I added structural buckling and dynamic event simulation. And I understand that a lot of you might be doing an internship, taking summer classes and whatnot. You guys might not be, very free. And because of that, I only require you guys to do these first 2 weeks and the 2 personal projects. Those are the only things you guys would have to submit. For structural buckling and dynamic event simulations, I'm going to open up a submission form, but you guys aren't required to submit anything. All right, let me just. All right, we should be good. All right, yeah. So we're gonna have 2 projects all in all. Oh yes, and here's what our schedule will look like. So today, and it'll run every Thursday up until the 13th of July. And on the 13th, by the way, it'll just be like an office hour where you guys would be working on your personal projects, and I'll be here on Zoom if you guys need any help or yeah, basically any help. Yeah. Okay. So here's a bit on what I want you guys to do for both projects. Now this is very like vague, and I'll get a lot deeper into it in week 2 and week 5 respectively when you guys are required to do that. But basically for project 1, I'm going to ask you guys to do a static stress analysis on a CAD model that you guys will make or you guys can find like outside. And after that, I will ask you guys to do a mesh improvement on that. But you guys will figure out how to do that in week 2. So don't worry about that. And for the second project, I'd like you guys to do a buckling stress analysis or a dynamic event simulation on Fusion 360. And why I sort of dedicate the 5th week entirely into the second project is you will come to find that setting up a buckling stress analysis and a dynamic event simulation takes a lot more work than that of a static stress analysis. But yeah, I'll guide you guys through it. So hopefully it's not too challenging. And again, week 3 and 4, when we're going through buckling stress and dynamic event simulation, you guys aren't required to submit anything. So yeah, all right. I'm just going to go directly into this. because we have a lot of things to cover today. So yeah, module 1, we are gonna get into introduction to FEA and Fusion 360. Cool. So CAE, if you guys don't know, is computer aided engineering. So it's basically the next step after you guys do CAD, right? So sorry, I'm just gonna go through all of this. Cool. Yeah. So instead of testing out your CAD model in real life, like say maybe you have like a plane wing, you don't want to make like 50 different designs and test out which is the best, right? So with CAE, and FEA is part of CAE. So with FEA, you're able to sort of simulate and test out your CAD models really quickly and efficiently, of course. And with FEA, as I've mentioned before, it's sort of like a simulation of what would happen in real life. So if I had this bottle, say, and I were to apply like 1,000 newtons of force on the bottle, right? I'll be able to see what happens through, in this case, fusion, and I would create the mess first of all, and second of all, I can really look at it in a lot better detail, I'd say. And yeah, basically, so here we have four different analysis that we could do with FEA, four of many, by the way. And this course will touch on 3, will not do modal because it's a lot of work. But yeah, if you guys are into FEA, I know if you're in ME, at least, I think you guys can take an elective on FEA. And if not, there's a lot of courses out there online for free that you guys can take that sort of delves into different FEA analysis. Next. Yes, okay. So you guys might be wondering about fluid mechanics, and that's another type of FEM, and that's called CFD. I'm sure you guys know it, computational fluid dynamics. This basically talks more about like air, water, how those will affect your models, your CAD models. And we're not gonna do that at all. FEA sort of deals more with the physical properties like forces, pressure, moments, and whatnot. But yeah. Okay, I'm just gonna go through this real quick. Yeah, so how does FEM work? Or let's make this a bit easier. FEA and FEM are sort of similar. So if I refer to FEM, it's probably the same thing as FEA and vice versa. So yeah, how it works is basically you have a CAD model, and the software will split your CAD model into separate elements, right? And these elements, each element will be solved using partial diffie-Q, and basically they'll calculate things like displacement and stress and all that good stuff. But yeah, that's basically it. And I'm not going to talk about this just because it's really boring. I'm going to leave it there for like 3 seconds if you guys want to take a look at that. Yeah, cool. Next. So where can we find applications of FEA, right? So these 3 I think are probably the most common ones, right? And I feel like if you search finite element analysis, these 3 will come up most. So fourth, these 2, here's vehicle suspension and wing structural components. You would use static stress or dynamic stress. While the building structures, when we're dealing with beams, this is a bit different, and that's when we'll use buckling a lot. We'll get into that later. But the advantages of using FEA, I've said earlier, is it reduces cost, and it helps us save time, and it also allows us to do iterative design improvements. So cost reduction and time efficiency, I feel like, are very straightforward, right? Like I mentioned earlier, you don't have to keep like actually like manufacturing physical parts to test. You can use your computer, change things up like a little and see what changes you guys get from making those little changes in your models. And iterative design improvement basically is like like generative design, if you guys have ever heard of that. And like mesh improvement, sorry, shape optimization is also a type of iterative design improvement, and that's something we're going to get into next week. Okay, cool. Right. So as you guys know, we're going to be using Fusion 360 in this course, but I just want you guys to know that there are a bunch of FEA softwares out there, not just Fusion. For example, with Siemens, they have NX, and for their FEA software, they have Star CCM. SolidWorks has SolidWorks simulations. We have Fusion. Yeah, we have Fusion. Autodesk has Fusion 360, and I'm sure you guys have heard of ANSYS before. But yeah, and here I just made a little diagram on like what FEA is in Fusion 360. These yellow highlighted ones are what we'll be dealing with throughout the course. Static stress analysis will be what we'll be doing today. We're gonna look at simplified just a little today, but next week we're gonna be dealing with shape optimization and structural and dynamic. Then week 5's the project. But if you guys do see here, there are a lot of other ones that you guys can get into. Unfortunately, we just don't have enough time. 5 weeks isn't enough to cover everything. But if you guys are interested, as I've mentioned before, there are courses online you can take. Or if you guys are part of a club, you guys might need to do other FEA analysis, FEA studies, sorry. But yeah, so one of the most important parts of FEA is actually meshing. I'm sure you guys have heard of that a lot, right? Creating your mesh this, mesh that. And basically what a mesh is you're taking your CAD model, right? You're taking your CAD model and you're breaking it into parts. Each part here will be called an element. And why we're separating each our CAD model into elements is because now our software, or in this case Fusion 360, they'll be doing a bunch of partial diff-EQ on each element here to figure out what the displacement at this specific element is, to give us accurate results basically, and sort of predict what's going to happen to our CAD model in real life if we were to subject it to certain forces or moments and all that. And we can, so if you guys see here, we can change our mesh settings to make our studies basically more accurate with the cost of time, right? So I'm going to show you guys what I mean. So here's our CAD model. This is the roughest mesh we could get. But if we want a more accurate result, we could split our model into a lot tinier elements, a lot more tinier elements. And we can do that up until we have this, where it's very hard to see each element now, because there's probably like millions of them. And Fusion will take care of everything basically. Like for every like dot you see probably, Fusion will run a bunch of like partial diff-EQ equations on it. Sounds like a nightmare, but thank God we don't have to do that, right? So that's the point of this course. All right, so another important thing within FEA is for us to define our materials. Of course, if we're going to run a study on our model, Fusion needs to know what exactly we're dealing with, right? So some important properties that Fusion needs to know are a materials density, Young's modulus, Poisson's ratio, and more. And you guys don't have to search it up yourself, because if you guys aren't familiar with Fusion's interface, they sort of have a library with a bunch of materials already. So that's good for us. And of course, next to that, we have to define our boundary conditions, right? Like for example, if the part earlier, let's say we're dealing with this, right? So if we don't fix anything, like if this is just like free and we add a force here that pulls our part here to the left, nothing's going to happen, because if you think about it, the entire like model is going to move along with it, right? So what we'd like to do is we'd like to fix a part, or like make a pin joint or something. So like let's say we fix this big hole over here and we add a force here that pulls to the left. Now we'll see something happen, like maybe we'll see stress buildup over here, and we'll see some displacement over here. But yeah, you have to define your boundary conditions when you're doing an FEA study. I said earlier, constraints, yeah. And the loads, those are probably the two most important boundary conditions you can have. And Contacts aren't very common, especially not in this course. Actually, scratch that. It's quite common, just not in this course, because contacts are used for an assembly. Like say if we're dealing with a table, contacts let Fusion know like the, what's it called? The leg and the table itself are in contact with each other, right? So that's basically the entire point of contacts, but we're not really going to deal with that unless you guys choose to do so for your personal project. And yeah, I mean, if applicable, you guys would also like to define your initial conditions. But again, this is not something we're going to do for this course. This is an example of what it'll be like when we pick a material in Fusion. As you can see, we're already given the physical properties, so we don't have to like put anything down ourselves. We don't have to research, which is great. Okay, so next up is results. Once we have completely prepared our studies, what do we do with the results, right? So after like just after this, I'm going to show you guys what a typical result of an FEA study will look like, but it's basically going to be like a bunch of colors, and you guys can actually, I'm just going to show you guys because it's a lot easier here. So this is what you guys are going to get. A typical result of an FEA study is going to look like this, right? So an example, we're looking at displacement here, right? So as you can see, we have a force pulling our part this way here. And we can see this red area means that's where like stress is more most concentrated at. And for displacement, at least, it shows us where in this model displacement occurs the most, right? So if you can see this blue part here with this slider, it tells us that there's no displacement happening here. But here, this red part at the other end, the big hole, there's quite a bit of displacement, right? And I just want to say that this is exaggerated. You guys see the number here? It's a very small displacement. I mean, you could say like that you can't probably see it with your own eyes, but Fusion likes to exaggerate it. So you'll know, like, if you keep increasing your load, like what exactly will the displacement look like, right? And what's nice is, again, as I said earlier, you can see the maximum and minimum, and this color gradient really shows you and it helps you visualize your results, basically. But yeah, sorry. And some additional steps. All right, so here, shape optimization is something we're going to do next week. What it basically does is when you get your results like this, and you have a safety factor of 15, which is like to a point of like it's too good. We're usually looking for somewhere around 1.5. So 15 means you're like really safe. Fusion will give you like recommendations here. Use shape optimization to remove unnecessary material. We're going to get into that next week. What shape optimization basically does is Fusion will run the study on your model, and it'll show you like sort of parts using a new mesh, sort of parts that you can cut away that will decrease your safety factor, but will help keep you within a range you specify, right? And another way you could do it, another way you could decrease your safety factor is, of course, using weaker and cheaper materials, like switching from metal to plastic, right? Cool. Yes. All right. So we're gonna briefly go into downloading Fusion. If you guys can raise your hand on like whoever doesn't have Fusion downloaded yet, because if I don't see any hands raised, I'll probably just skip this part entirely. Just give me a sec. I don't really know how to check if anyone has their hands raised. Okay. Cool. Okay. Cool. Yeah, I see 2 hands raised. So I'll go through this briefly, and if you guys can't keep up, please do let me know. I'm gonna probably spend about 5 minutes doing this, although the download itself will probably take about 15-20 minutes if you guys are doing this right, and it can be hard to do it right, so I don't blame you guys. But okay, let me just explain why we use Fusion first. It's easy to use, it's very intuitive, and it's free. That's basically the main point. And also it's cloud-based, so if you guys don't have a strong laptop, if you guys are using say a MacBook, you guys can still run your studies without a problem. So yeah, get into it. So how do we download Fusion, right? So you want to open up Google. You want to go to this address here, or in I've sent the link in one of the emails. You guys would like to go there, basically. And the link I sent from the email, if you guys click on Fusion 360, you guys should get this screen, and you want to sign in. But since you guys don't have an account, I'm assuming you would like to go down. Sorry, give me a sec. You'd like to go down here, create account. And what you'll see after you click that is this interface, right? Then after that, you'll get, okay, sorry. After this, you should be good. They'll probably ask you for verification, take a picture of your PU ID. If I'm not wrong, that's what I got last year. But after you've done that, you should be good. Now, if you have any problems, please let me know through Slack or email. We could set up a Zoom like office hour, like super informal, one-on-one, or like however many people can't download Zoom. I mean, can't download Fusion. We'll figure it out. But for now, I'm gonna keep going. But yeah, again, for those of you who don't have Fusion downloaded, please do email me or send me, actually send me a Slack. Send me a Slack and we can figure something out. Okay, we're gonna get started with creating our study. Now we're gonna get right into it. So in the email I sent about an hour ago, I attached a file called analysis.f3d, which is a Fusion file. If you guys could download that and open it on Fusion, that'll be really good. And if you guys have done so, please give me a thumbs up so I know when to continue. I'll give you guys about like 3-4 minutes to do so. Okay, that was quick. Oh, wow. Okay. Let's wait for the others. Thank you, Samuel. Let's wait a bit more. Cool. Thank you. Thank you. Okay. I see you have your hand raised. Xiaohui. Would you like to? Okay. If you have a question, you can pop it in the chat or unmute. Cool. All right. Well, I am gonna keep going. If you guys have any issues with that, please do let me know through the Zoom chat. If not, if I just keep going and I don't see your chat, I'm sorry, but please do let me know on Slack. We'll figure something out. I'm sorry. But okay. Okay. Cool. Okay. Gotcha. All right, let's keep going. Cool. So first thing you want to do is make sure your units are in millimeters. This is how you do it. You want to go to document settings, change your units to millimeters. And let me just go to Fusion real quick so I can show you. Cool. So this is what you guys should see when you open analysis. And how you guys change your unit to millimeters is from this drop down here, document settings, click on that. Your units might be in inches. Going to go here, change active units, and change your unit type here, right here. Now you want to be in millimeters. So I'm already in millimeters. I'm going to click that. Click OK. You guys can set as default, just because for the rest of this course, you guys are sort of expected to use millimeters. So I'd say that's a good idea. I'm going to click on that. I'm going to go back here. Cool. So now we're going to analyze the 3D model. Just by looking at this model, you guys tell me like where the weak zones are. So if you guys didn't know, stress likes to build up usually on edges and corners, like these points over here, sharp corners here, like stress builds up there. And a good way to minimize stress and minimize your weak points. Down here, we have two fillets that are suppressed. If you guys can unsuppress that, you guys will see that, sorry. You guys will see that now we have curves. Basically, what this does is make sure that we have no stress buildup at any specific point within the model, right? But that's basically all I wanted to show you. Please do suppress these two features, these two fillets. Yeah, suppress these two when doing your analysis just in a bit. But yeah, I'm gonna keep going here, swipe here. Cool. All right. Sorry. Yeah, okay, sorry. I went through that already. Okay, now's the fun part. Let's start creating our study. So first thing we want to do is we want to switch our workspace from design to simulation and create a new study. I'm gonna go through along with you guys. Let me just do this. Okay, cool. Sorry. Cool. So you're gonna go here. You're gonna switch from design to simulation, right? So I made a mistake sending you guys the file, because if you guys go with the simulation here, just put this aside, you guys can see that it's a whole different part we're working with, right? So that's a part that I edited last semester. So we're gonna fix that first. What we're gonna do is go simplify model here. We're gonna simplify like this. If you guys can see on the bottom, there are these sort of edits to the model. Please do delete all of them. You're not going to be working with this part. We're going to be working with just the ordinary part, the one you would see in the design workspace. And once you're done with that, please do finish simplify. Up to this point, do you guys have any questions? Okay, cool. So doesn't seem like anyone has any questions, so I'm going to move on. You guys can see here, there are a bunch of studies you guys can do through Fusion. Static stress is which is what we're going to be doing today. Of course, modal frequencies. If you're dealing with electronics, just want to see thermal stresses, you guys can do this. And then week 3, we're going to be dealing with structural buckling here. Week 4, we'll be dealing with dynamic event simulation. And throughout week 2 and 3, we're going to be doing shape optimization, but we're going to deal with that next week, right? For now, I just want you guys to click on static stress and hit create study. And I'll go back to our slides for a moment while you guys are doing that. Cool. And again, I showed you guys the simplify tool, and why it's useful is you guys can change your model up without actually changing the actual model on your design workspace. Like you saw earlier, in our design workspace, we had this sort of basic model. And right as we entered our simplify workspace, it was a whole different model, right? So take advantage of that when you guys are done with this course, or using FEA now for your clubs, jobs, whatever you guys are going to use it for. Take advantage of that, play around with it if you guys want to change some things up just a little bit without actually changing your CAD design, right? That seems very useful. But yeah, okay. There you go. Cool. Let's keep going now, right? So as I mentioned earlier, one of the fundamental parts of FEA, one of the things you really need to define are the materials, right? What material is your part made of? That's exactly what we're going to do. So how we do that is you go to study materials and we pick a material from a list basically. And I guess I'm going to give you guys like 5 seconds to read the rest of that. And I'm going to go to Fusion and show you guys how to do that. Alrighty. Now we're here. Okay, now we're here. We go to materials here. This one over here. We can click the drop down. There's a bunch of things you guys can go look at, but this is enough. Study materials, click. Now we see here our study material and from what library it's in. But we'd like to change, okay, and there's like a bunch, like there's, yeah. We'd like to change it now to aluminum, right? Just change it to aluminum. That's what we're gonna be using. Click OK. It should turn white. That's the color of aluminum. Another way we could do it is by hitting study materials here. It's going to take us to the exact same interface we saw earlier. But yeah, I mean, you guys can pick, right? It's the same thing. Once you guys are done with that, you guys are good. Let's keep going now. And the next thing we'd like to do is apply our constraints, right? We'd like to apply our fixed constraints so that when we apply a load, something will actually happen. What we're going to do now, we're going to fix our bigger hole, the interface of our bigger hole, right? And we want to make sure that it's fixed in the X, Y, and Z axes, right? Because if we, okay, I'm going to show you guys here actually. So you want to go to constraints here. You guys can drop down here, but for the most part, we're just going to use the basic constraints. So just click on that. And you guys can see the different types of constraints you guys can apply to your model. We're just going to use the fixed. We're going to apply it to the bigger hole of the inner circle of the bigger hole. Sorry. I'm going to click that. Make sure all three axes are highlighted. We're going to click OK. How you guys know you did this right? Because if you zoom in, you guys can see this lock is actually locked. Probably hard to see. Let me do this. Cool. Yeah, it's probably easier. Now, if you guys did this wrong, say I just fixed the X and the Z axis, what you guys will see is your lock is unlocked. What that means is it can still move in the Y direction, right? But that's not what we want. So let's fix all three axes. Cool. Let's just go back here. Alrighty. So now we're going to move on. Next thing we want to do is apply our load. So again, this is an introductory course, so it's going to be very simple. The only load we're going to apply is basically a load that pulls our part, right? And here is the load we'd like to apply. I'll give you guys about 10 seconds to read that. So basically, we just have to click structural loads and select force. Make sure you guys select force, not remote force, not moment, not pressure, but force from the type. And we'd like to select the interface of the smaller hole this time as our target. And for the angle, it's a bit different based on everyone might have different ones. So I'll just show you guys what the direction of the force is supposed to look like. Okay, so now we're back here. Again, your bigger hole, the interface of your bigger hole should have a lock on it, right? And that's how you do it. So go constraints, fixed, and select that. We've done that. Next, we're going to apply our loads again. Use the drop down. Again, it's this introductory course. We're going to use the most simple one. From type, pick force, right? Not remote force, not moment pressure. We'd like to use force. For our target, please pick the interface of our smaller hole. We click that. And this is the direction we'd like to use, right? You guys can see earlier, it says we'd like the X angle to be 180 degrees. But if your direction's already pointing outwards like that, please do not change it. This is what we'd like to see, right? Out. If you guys have a force that looks something like this per se, then please do change it or use the dragging tool here to drag it outwards. Okay, this is the direction we'd like it to be in. And we'd like to change our magnitude. We can change our magnitude through here or here, doesn't matter. Make that 1000. We can change our units, by the way, but let's keep it in newtons right now. Click. Can I get a raise of, oops. Yeah, actually, can I get a raise of hands on if you guys are done with this step? Actually, thumbs up or a raise of hands would be good. Yeah, okay, I see you, Nick. Samuel, thank you. Thank you. All right, thank you, guys. Thank you so much. All right, it's like we're doing well here. What? Okay, sorry about that. The next thing we want to do is generate our mesh. Like I said earlier, we want to sort of break our model up to separate elements for Fusion to analyze, right? How we do that is we could click on the mesh icon here. Okay. So there are a lot of different ways you can set up your mesh settings. Today, we'll be setting up our mesh in the most simple way possible. Next week, we're going to get a little deeper into it. We're going to look at the advanced settings here, as well as the adaptive mesh settings. But for today, just simple average element size should be enough. And yeah, the one in red here, always click on generate mesh, and I'll show you why we need to do that and what that means. But yeah, let me show you guys how to do that here. So here, below the eye, we have mesh, right? Click on edit here. That's going to bring you to this interface, right? We have average element size and advanced settings. We're going to be dealing with this next week, so you guys don't have to worry about this this week. We'll go through it next week, and you guys will understand what each of them does. But for today, we're just going to be dealing with model-based size, and let's keep it at 10%, right? Let's keep it at 10% first. We're going to click OK. Now, we're going to click this I button here. It's basically going to create the mesh for us. Might take a bit. Cool. Now, if you guys can see here, our model is now split into separate elements. Each triangle here is an element, right? Cool. Now, we could also go to mesh from here. Drop down over here. Let's go to local mesh control, sorry. That's if we want to change our mesh at a specific designated area. Like if we'd like to change our mesh here or here. That's not what we're going to be covering today. We could simply go to settings, click here, and down here we have mesh. We could also edit our mesh through here, change it to 1%, right? And yes, just click yes here. And if you guys can see here, Fusion is giving me a warning here. It's telling me it's out of date. That's why we'd always like to generate mesh. Every time you change your mesh, just make sure you guys right click here and generate mesh, right? Just to be sure you guys are dealing with the most recent mesh you guys picked, right? If you generate mesh here, this is just an example. 1%, it's going to be a lot finer, as you guys will see in a bit. But the downside of that is when we do analyze our study, Fusion's going to take a lot more time to solve this study, right? Look at that. Now, each element is this individual triangle here, and Fusion has to solve for a bunch of them, right? But please change this back. Actually, let's change this back to 10%, so your studies won't take a long time to solve, especially since we're dealing with a part that's not too big. We don't really care how accurate our results are, though I will be asking you guys to change, play around with the mesh in a little bit. But for right now, just keep it at this 10% mark because it's enough. Cool. Yep. So next thing we'd like to do is to use our pre-check tool, which is one of the most important and I guess one of your biggest friends when using Fusion's FEA. And why that is that the check tool actually lets you know if you're good to go, right? So if you set everything up right, this is sort of what you should be getting, which is a check, right? This means like, all right, you're good, like you're ready to solve. Whereas if you guys forgot to do a step, this is the interface you guys will be introduced to, right? And Fusion usually is able to catch like what you're missing. Like for example, here you're missing a structural load, so Fusion will be like, hey, maybe you're forgetting to set up your load. But if I'm gonna swipe back here, guys, we look at our pre-check tool, which is over here. You can see it's green, right? Now, of course, if you hover over any icon, it tells you sort of what it does. But all right, back to it. Our pre-check tool is green, which means we set everything up right, and Fusion's telling us, all right, you're good to go. We can solve whenever we're ready, right there. It's not giving us any warnings at all, so we're ready to solve. So once we're done with that, we're gonna solve. I'm gonna solve. Solve is right here next to pre-check. We're gonna solve here, and should say ready. Once you guys are done, just click solve one study. It's gonna ask you guys to name it. Just name it whatever you'd like. I'm not really too picky because I'm not gonna ask for the file. But yeah, it's going to give you the status. By the way, it might take about like 5 to 10 minutes. So please be aware of that and please be patient. Please be patient. Um, but that's basically how you guys would set up a static stress analysis. Up to this point, does anybody have any questions? Probably went through that really quickly. So if you guys do, I don't blame you. Okay, cool. Looks like we are good. And by the way, if you guys want to check on your study, like earlier, I just clicked X. Now I don't know where to find my study. One thing you could do is go to job status. It shows you that you're 30% done. Another way you guys can check is here. It shows you sort of it's a lot less like intuitive. Like you can't tell that's 30% maybe, but it shows you that it's still in progress, right? So go back here and okay. So let's wait for this to solve actually so I can show you guys the results tab. It shouldn't take too long. So while we're waiting for that, I'd like you guys to please follow along because this is very important. Please change your account here. Go to preferences. So click up here and go to preferences. Once you're in preferences, please go down to tokens and cloud credits, right? Up to this point, are you guys able to follow? Because this is really important. Give me a thumbs up if you guys are here. Cool, 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 cool. Cool. Thank you guys. All right, I'm gonna keep going. Once you guys are here, you guys can see you have your personal accounts here, which is a bunch of weird combinations of letters and numbers. And as you can see, my balance is 0. If you guys are using the FEA tool for the first time, maybe you should have like 6 or 5. But you guys can see here, you have another account called education. And you guys would probably get this account if you guys signed up using your Purdue emails, which I'm assuming all of you have used to sign up for this. And if you use your Purdue email, you'll get an education account with unlimited balance. Now, why this is important is because usually this is set up as your personal account by default, and you guys will need to change it yourselves to education. So again, it's just do the drop down instead of having this 4-3Q or whatever combination you guys have. Please switch to education so you guys have unlimited amount of credits. And I'll wait for like 5 seconds. And if you guys are done with that, can you please give me a thumbs up so I know you guys are able to do so. And this is important because next week, when we do shape optimization, we're actually going to need about like three cloud credits per shape optimization. If you and we'll need to do like 4 or 5 shape optimization. So if you guys don't switch it to your education accounts, by like the 3rd simulation, you guys will be out of cloud credits, sorry. But yeah, thanks for the thumbs up, guys. That's really important that you guys switch to this. Yeah, let's check on our, okay, there you go. So when our simulation is done, once our study is done, we're gonna be directed to this interface right here, right? And it's a similar interface we see here. So results details, right? And again, shows us that our safety factor is 15. Like we have unnecessary material that we can cut down on, which we're going to deal with next week. But I just want to show you guys what you can do with the results that you guys have here, right? So I'm going to go back. So with the results tools, you can play around with different variables, and you guys can also animate your model going through the specific scenario that you guys put it in. In this case, 1,000 newtons of force that's pulling on our model, right? And you can also check the deformation to see difference between the undeformed model when whatever force you applied hasn't been applied yet, and the actual model, which shows you what your model will look like after you apply your force without any like exaggeration. And adjusted is when Fusion sort of exaggerates the results just a little bit so you guys can actually see what's happening to the part. Okay, and I'm gonna walk you guys through how you guys can use each and every one of them because it's very important. And I guess I could use displacement because it's has the color gradient, which makes it easy to see. Now, first things first, you guys can take a look at displacement, safety factor, stress, reaction forces, and more. But for the most part, in this class, I only want you guys to go through safety factors, stress, and displacement because those are what I'm requiring you guys to send me for your submissions, right? I want to see here, safety factor, stress, displacement. Like, okay. And then results tool here. Bunch of things you can do, right? You guys can play around with the slider here. So, yep, you guys can do that. And again, here you can check the undeformed, actual, and adjusted. So here's what I want to show you guys. So this is our undeformed model, right? This is what our model will look like. I'm gonna go to our view here. And if you guys actually see the actual, you guys can't really see a difference. Now I'm gonna zoom in a lot here, just so you guys can see maybe a little bit. That's how much deformation our model actually has with 1,000 newtons of force, right? It's not that much, but somehow Fusion showed us this, right? So please be sure to switch to actual. Or, yeah, okay, sorry, someone put something in the chat. I will take a look at that in just a bit. But yeah, so please be sure to switch to actual if you're actually looking at, if you guys want to see how specific force, pressure, moment will affect your model, right? Cool. And is there anything else I was missing here? Oh, the animate tool. Yes. So you guys can also animate here. What will happen to your model, right? There you go. Kind of cool. I don't know. But yeah, those are a few things you could do with your results to results tab here once you're done doing your study. Okay. Other things you could do here, oops, sorry, with your results are you could hide your minimum and maximum. You guys can try it out, but please turn it back on because I'd really like to see these values when you submit your work. And of course, you guys can create a point probe here. And here you can actually see what the stress is at this certain point. And why that's possible is because earlier Fusion, sorry, not Fusion. Earlier we created a mesh, right? We created these meshes here. So Fusion is able to tell at this point, at this quote unquote element, what the stress is or what the displacement is and all that, right? But yeah, those are a bit of what you can do with the results tab in Fusion. All right, so now we are going to go to our assignments. So what you guys saw earlier, I'd like you guys to do 4 things. Well, 3 things in total. If you guys followed along with me as we created and set up the study, this counts as 1. I'd like you to provide me 3 screenshots. So 1 screenshot of the safety factor, 1 screenshot of the stress, and 1 screenshot of the displacement, right? Once you're done with that, click finish results. And please don't edit this, right? Don't go down here, go to your loads and edit your load, right? Please keep it as is. What I'd like you to do instead is right click on that and clone study. Once you've cloned your study, everything will be exactly the same, right? You create your mesh here, it'll be the same. Sorry, give me a sec. But again, we'd like to change the value of our load to 5,000 newtons. And I'll let you guys figure out. No, actually, let me show you guys how to do that. And for the rest, I'll leave it to you guys to figure out how to do it. And I'll be back in about 5 minutes to show you guys how to do it. And please do screenshot the results. So here you go to edit, or so again, once you've duplicated your study, once you've cloned your study, sorry, so here, right click on study one and clone study, right? You get this. And then once you're on your study two, here, you'd like to click this drop down, go to loads, drop down again, and go to force. You want to edit. You can double click or click this edit button here. And you want to change your magnitude now to 5,000, right? That seems very simple. Into 5,000, you should be good. And earlier, I taught you guys how to change the direction of your load, right? Change the angles, basically. And so there's no confusion. I just want to let you guys know. This is one. So 1,000 earlier, like I mentioned. You do this, give me 3 screenshots, good. Change the load to 5,000, give me 3 screenshots of this, good. Now change it to 10,000, give me 3 screenshots. That's good. So that's 9 in total. And then I'd like you guys to clone another study of 10,000. And instead of changing the magnitude, change the direction, right? Change this direction to include a Y angle of 90 degrees. And again, I told you guys earlier that the angles might be a bit jumbled up based on your own fusion. So here's the direction I'd like you guys to have your 90 degrees in the Y-axis to look like. Right click here, edit structural load. I'd like you guys to have, so I'll do it 2 ways, so it's intuitive, to have it as 90 degrees here, which you guys can use the slider here, around here, 90 degrees. So it's pointing downwards. How do we fix the model to the correct one again? Okay, so yeah, let me show you guys how to do that. And another way to do it is just by manually typing 90 here. Okay, so how do we fix the model to the correct one again? Are you talking about the constraint? How do we constrain the model?
No, my 3D model is
Yes.
the weird one with like 2 or like the hole in the middle.
Oh, okay. I see what you're talking about. Okay, so how you do that is you want to go to simplify here. And when you go to simplify, you should see, because I removed it, there's nothing for me, but you should see like there should be like a fillet and like an extrude down here. Is that what, do you see that?
Oh yeah, I see. Yeah, I see there's 2 fillets and 1 extrude.
Cool. Okay, yeah. If you could right click on each of them and then just delete them.
Just the fillets?
All of them.
Oh, the fillets and the extrudes?
Yes. Did that work?
Okay, yeah. Awesome. That worked.
Cool. Thank you.
Thank
yeah,
you.
I'm gonna give you guys about like what 15 minutes to set up your studies because you just have to clone and change the loads. And give me a sec here. I'm just gonna reply to the chat real quick, and then I will show you guys how I expect you guys to submit your submission. Cool. So, okay. See, there's another chat here that just popped up. Yes, yeah, for sure. So this is the interface you guys should be seeing right now. And if you guys still have the hole in the middle and a janky looking fat wrench here, which I apologize for, please go up here to simplify. Just click on that. And what you guys should be seeing is features down here. You guys should be seeing some features. Yeah, like what Vaishnav said earlier, there should be 2 fillets and 1 extrude. Please right click on all of them and just delete them. And okay. And could you please give me a thumbs up if you guys got that covered? I think that was Thorin. Really? Okay. Thank you so much. Okay. If you guys still have a problem with that, please do let me know in the chat. Oh, I see. Okay, no problem. Yeah. If you boot up your Fusion and it still doesn't work, please let me know. But right now I'm going to show you guys how I expect you guys to submit your work for the next 5 weeks. So I'd like you guys to put all your screenshots in a document. I don't care what the title is, but I'd like you guys to follow this format. And by the way, if you guys can't get all of this within the next 5 minutes that I'm going to be explaining this, please don't worry. I'm going to be posting this in a Slack message tonight, along with the link to the recording, so you guys can watch this lecture again if you guys did fall behind, and for all of you that aren't here today with me. So yeah, here is what the format is. So of course, first name, last name, assignment name, just put week 1, week 2, week 3, week 4, something like that. Task 1, I'd like you guys to specify what screenshots I'm looking at exactly here. So 1,000 newtons, show me. Please put displacement, stress, and safety factor. And it should be a bit easy because it shows right here. There's displacement there, stress there. And one thing I do want to note is for stress, make sure your stress is at von Mises, right? I'm going to go back to Fusion really quick to show you guys. And by the way, if you guys are back here and you guys would like, and you'd like to see your results again, you don't have to solve it again because it's already solved, right? Sorry, this one isn't solved yet, sorry. Yeah, okay, so over here, and you'd like to solve it again, you don't really have to solve it. Fusion doesn't really let you solve it anyways. Just go up here to the results tab, simulation results, and it goes back to where we were earlier today. And again, for stress, make sure you guys are at von Mises, and for your units, make sure it's at megapascals, right? So there's a bunch of this here, but please keep it at von Mises. And one more thing I'd like you guys to note is if your values don't exactly correlate to mine, don't worry, you guys probably aren't doing anything wrong. But I just want to make sure that it's within an acceptable range, right? Okay, so back to the document. So yeah, displacement, stress, safety factor, those 3, I'd like you guys to screenshot, right? And some important parts of your screenshots are that I'd like to see the date and time, right? Please don't crop your screenshot so it's, I'll show you guys what I mean here. Cool. Please don't turn off your minimum, maximum, no timestamp here, and no legends here. Please keep all of these in, right? Just include all of them. I really do want to see it. Another way is here. Still no timestamp and no minimum, maximum values. This is still bad because there's no timestamp, right? So please make sure all of those are included, right? Your timestamp here, very important. Your legends here. Your minimum and maximum values are also very important, okay? And I know that was quick, so I'm just gonna go through it on Fusion, show you guys what I mean, right? So here, you guys can see down in the bottom, I have my timestamp here. So that's good there, right? Let me go to results here. I have my minimum, maximum. Again, if you guys accidentally turn it off, it's right here. Just double click, just click it, and you guys should have it back, right? So please have this too. Have your timestamp and have your legend here, right? And yeah, that's how I expect you guys to submit your work every single week. I will wait probably like about 5 more minutes. If you guys are done with this, please do give me a thumbs up so I know you guys are done. I don't want to wait too long. We have just a bit more to go through before we'll be done this week. This week's probably not going to be as long as the other weeks. And I just want to give you guys a quick heads up for all of you watching the recordings who are planning to join next week, and all of you here, of course. Next week's going to be a bit tougher, I'd say, because I counted in total, you would have to submit 59 screenshots. So bear with me here. I'm trying to sort of contact Milestones to see if there's any way I could decrease that number, just because in the previous semesters, that's sort of how we've been able to sort of grade you guys, is by your screenshots. So yeah, please bear with me here. I'm trying to figure out a better way to check all of your work without having you guys submit like 70 or 80 screenshots in total within a span of 5 weeks, right? But yeah, give you guys 5 minutes. Once it's 6:40, let's make it 42. Once it's 6:42, I'll continue, and I'm gonna keep my screen now at this page so you guys can take a look at that if you guys missed it. And sorry, I'm just gonna stop video. Yeah, okay. So sorry, let me go back here. The question is, what constraints do we use? Right, so let's go back here, finish results. I'm gonna go to study 2 so I don't mess up the study I'm done with. So for our constraints, we'd like to keep it as we did for study 1. Just for, I guess I should have mentioned that. For all of the variations you guys are gonna do, make sure you guys fix this bigger hole, the inner circle of the bigger hole. For every one of them, make sure they're fixed on these 3 axes, right? So when you're dealing with the 1000, it's fixed here, 5000 fixed here, 1000 fixed here, and when you guys make the load, sorry, give me a sec. Once you guys switch the load up here 90 degrees, please do keep it as a fixed constraint within this interface of the big circle, and make sure it's fixed on all 3 axes. Thanks for the question, Vaishnav. Yeah, let me go back. Sorry. Let me go back here and let's wait about how many minutes left we have? Yeah, like 2 more minutes. Okay, cool. Hopefully you guys are done setting it up. I know waiting for your results to come up might take a while, but that shouldn't be a problem. You guys can keep your laptop up and just do your screenshots whenever. Make sure to save your Fusion But okay, let me actually show you guys. Make sure you guys save your studies here, so you guys can close it and come back to it and make like it'll still be there. But I'm gonna move on with this. I don't think there's much left. But yeah, let's see. Okay, the next thing we'd like to get into is linear versus non-linear material, right? Like, let's say you'd like to run an analysis on a wooden table, right? Wood is a non-linear material, right? Some of its properties in the X and Y and Z directions might not match up. Like an example, a very good example is actually their Poisson's ratio. So how exactly would you do a study on a non-linear material? Now for this, there are two ways to do it. I'm going to show you guys right now. So actually, let me go through it. Okay, I guess I didn't write it down. Okay, sorry about that. So there's two ways you guys can actually do a study on a non-linear material. Now, one way, which I would say is the better way because it's a lot more accurate, is when you guys go to simulation here, instead of, oh, I'm already in simulation, sorry. If you go to study here, instead of going to static stress, there's a specific one for non-linear material. So here. So that's a better way to do things, but it takes a little more, like, I wouldn't say skill, I would say experience. Some boundary conditions you might need to change. So I'll just go for the more simple one, which might not be as accurate, but you guys can use this as a very rough estimate on results when you guys are doing your analysis. And how we do that now is by going to our materials, more specifically, I'm going to show you guys actually. So how would you guys know if you guys are dealing with a non-linear material, right? I guess that's a good first question to have. And of course, I mean, we can't do a simulation on air, so let's not worry about that. But okay, down here, you guys see bamboo, birch, canvas, cherry. They all have an exclamation mark or warning right next to them. And these warnings basically is Fusion telling us like, hey, this material is nonlinear, right? And that's the materials that we actually have to change, right? So how do we change them? Well, instead of going to study materials, we need to go to manage physical materials, right? And once we're here, this is sort of the interface we're greeted with, and how you guys would create a non-linear material is by going to the material library and picking first a non-linear material you'd like to do an analysis on. So for this example, I picked birch, and you'd like to right click on birch and add to favorites. Then here you can see properties. As I've said earlier, non-linear materials might not have the same physical properties on the X, Y, and Z direction, right? Although you guys can see here, thermal expansion coefficient for X, Y, and Z, same for birch, thermal conductivity, same for birch. Let me just go here myself. So again, here, manage physical properties. When you're here, you'll be greeted with this. Pick whatever you want here. So we could go to wood, click birch, right click here, add to favorites. I've done that already, so I'm not going to do it again. Here I have aluminum and birch. We go to birch here. You can double click on birch. If you double click on birch, that's how this interface will show up. That shows you the physical properties here. But yeah, like I said earlier, the X, Y, and Z are the same for our thermal properties at least. But once we go to our mechanical properties, we'll see our Poisson's ratio is different for every axis. And that's why we can't do a static stress analysis that easy, right? So how do we get around that, right? If we don't want to learn a lot of new things, how do we do that in a lazy and rough way? Doesn't sound very nice, but okay. How we do that is actually by copying whatever whatever properties we have here for our thermal expansion coefficient, specific heat, thermal conductivity, to a linear material. So here we have aluminum, which is a linear material. And how we get it to appear here as well is, again, by going here. We have our metals. We have our metals here. Right click on aluminum and add to favorites. Right. That's exactly what I've done. And that's where I'm at right now. Right. So I have these two here. And if I double click on aluminum, actually it's already here. Cool. Yeah. If you look at aluminum here, look at the Poisson's ratio, look at the specific heat, the thermal expansion coefficient. It's all singular, right? Because it's a linear material. So if we want to do a very quick rough analysis on birch, what we could do is take note of the properties of birch here, right? And just edit our copied aluminum here to that of birch, right? And if you guys are worried, like one thing I was worried about when I started doing this was, all right, well, now when I use aluminum on, say, my study here, then it'll be birch technically, right? It won't be aluminum, but that's not the case, because when you add things to your favorite, it basically duplicates it, and that's why you'd like to change the name. You could change it. But yeah, that's basically how you do a very rough estimated study on a non-linear material. For your information, you guys won't have any tasks that require you guys to do that. I just think it's worthwhile to learn about and know, and also fills in the time because week 1 is usually very quick. But yeah, that's it. Let's move on. Oh, well, that's it. Okay, well, that's it for this week, guys. Here's the submission link. I will also drop this link down in the Slack chat once we're done with this meeting, and once the submission, once the recording is done being processed and being uploaded to YouTube. I'll drop the link for the recording as well, the attendance form, of course. But yeah, that would be all. Thank you guys for sticking with me. If you guys have any questions, please do stick around, unmute yourselves, but I am going to stop the recording now once I figure out how to stop this recording.